um, how the communication pathway can be improved for students to learn more about career opportunities and the value of higher education, and just the impacts of the time they spend uh, can benefit them. Another point that we wanted to hear about was a greater diversity of available careers. The students feel like we hear a lot of people uh, in like academia at institutions, and then for the people who represent the industry, we see people who kind of jump into something adjacent. We were wanting to see if there's anything in that in between area. The third, we want to see uh, how you can work on a mentorship structure, both lateral and vertical, so that there is intercommunication. And the fourth thing we wanted to see was an openness in academia about the culture. So how is it to work with XYZ professor? How is this university? What what's the feel there?
Thank you so much to you and all the students for participating and sharing the results. We want to make sure that all of these as well get put on the shared document. Jennifer, are you comfortable reporting out on the session you were the nucleus for?
So we were discussing technical platforms and ways that we can share software and tutorials and resources and things like that. We had a really great discussion, and hopefully we'll be following up with each other on that, looking at under the sort of umbrella of the Rubin Undergraduate Network and using GitHub as a platform to create curated list and sort of an index that would say, if you're trying to onboard astronomy students doing research on this topic, this tutorial and this tutorial and this section of that tutorial are really good resources. And then have a way for professors to sort of sign on that they've looked at these tutorials and they're useful, to be able to broaden out the ability of us to quickly use things rather than having to reinvent the wheel. And again, there's really great tutorials out there, but they're not all aimed at an undergrad accessible level. And so the idea of taking some of like the Rubin tutorials, but then adding on the layer of, for undergrads who don't understand any of this yet, what does this mean and why are we doing it and how is this going to work? And I know there were other people, I wrote down some notes, but I'm happy to have other people contribute to those as well.
Thank you so very much. And I think we had a fourth session in the room, I think. Yeah. Oh, yes. Are you more comfortable with Andrew reporting out, or would you like to, Alma? And then Andrew, after you report out, then you'll handle the online results.
Great. So our group was talking about some of the challenges related to having international situations and not everyone having data rights, and how can we involve students in that sort of some of those projects. So some of the things we had talked about, focusing on sort of the methodology, that like rather than having to work on the data itself, but like the things that go into the pipelines are sort of more general than you don't need actual data for. Also, the existing open data sets that are precursors to Rubin, and things like DP0, which are public, or some version of them are public. Some of the science collaborations are open to non-data rights holders. Many of them are not. And so, but there are maybe ways of making use of some of the things like the strong lensing data challenge. And there's also some ambiguity about the JA designation, whether the undergrads count for that as well. And so, not that we want to sort of force a solution on that, because that might foreclose a pathway, but that some things to explore. Is there anything else? Okay, great, thank you. Sure, yeah, and no one else volunteered for the online to share out, so I'll do a review of sort of things they talked about. They had a number of discussions about using the online sort of data sets like DP0 and the trying to make use of online advising of students over Zoom might sometimes be a lower barrier to entry, I guess, and be able to make use of professors' time and students that are in various living situations to be able to rather than force them to come to a group meeting that might be more flexible. There was also some conversation about with Jesse Mason's if it were just one professor that were sort of the PhD expert that was the center of the collaboration group, that would be is difficult to maintain for if it is only a single faculty member, right? Whereas if there's a network of faculty member from Michigan and Wayne State, that if there was like several working together, then any interruption of one faculty member's ability to contribute to a project would not necessarily tank the ability for the research group to be able to continue and make progress for over this longer period of time that it takes to do projects.
Great. And thanks to everyone that contributed to those discussions. And if your group was not able to put your notes into the shared document, email them to me and I'll get them in the document. There's no problem at all. And so, right, we heard a lot of amazing stories in the first part of this workshop. And just to emphasize, so we're supported right now. A lot of people are able to be in this room. We had lunch thanks to the Heising Simons Foundation, who've been so supportive of this work. But as I said this morning, the nature of any of these things is you get a few years of soft funding and then have to keep going back. So the funding that supported that what Jesse talked about that came from the Alliance, that has now been retired. The funding that's supporting what we heard about from Leslie and also John, this is the last official year of that. So you can help us get money to continue programs like this by telling us your stories. Right? A lot of people didn't have the chance to share their stories in the first half, and not just your successes, but also the barriers and the struggles and the things you're missing. And I'm going to post some information about that and ways that you can get your stories to us. Again, it doesn't take a lot of time to share your stories, but just give us your information, what's going on to help us then help you in return. And so with that, I'm going to be actually a little strict about timing for talks so that we have a bit of discussion time at the end. Let's hear from Melissa about the Rubin Delegates program. Yeah, I know it's ignore my slide. And then we've got delegates here, slideshow there.
Okay, great. Thanks, Beth. All right, hi, my name is Melissa Graham, and I'm the lead community scientist for Rubin Observatory. And I'm going to tell you about what was called the Delegates program. So Delegates was associated with Data Preview 0, and that was the first release of simulated data from Rubin Observatory. Data Preview 0.1 was released in June 2021. And at that time, the Rubin Science platform was limited to 300 accounts. It was a brand new platform, and that's how many we had. So when we are limited like that and how many people can access the data, we needed an application and a selection process. Because there was that selection process, we adopted the term delegate to reflect how these early participants were representing the broader science community as learners, how they were providing feedback to Rubin Observatory about this new Rubin Science platform, and how they were then going and sharing what they learned back with their local communities. So they might be like the only one in their local department that was participating in this. So thereby they sort of become the Rubin expert in their local place. So we called them delegates for that reason. And there's a whole tech note that was sort of, we kind of really thought about this in advance and wrote out all the guidelines for community participation at this early stage. And that's all in ls.st/rtn004. This delegates program continued as DP 0.2 and 0.3 were released in 2022 and 2023. And over those years, the limit of 300 RSP accounts was increased to 600 and then 900 people. While we were having these delegates come and start to access data, we, and by we, I mean the community science team and Rubin Observatory in general, we ran a bunch of programming for delegates. That included things like a bunch of Data Preview 0 kickoff info sessions whenever a new data release came out to help people access the data. We ran weekly Data Preview Zero delegate assemblies, which were usually a mix of like hands-on tutorials and presentations and co-working sessions. We were running the Stack Club, as it was called at the time, where the stack is like the colloquial term for the LSSD science pipelines. So Stack Club had been sort of a longstanding thing that we had adopted. And every other week, Friday morning for 2 hours, it was just kind of an open co-working session. We were running third Thursdays back in this time. It was a monthly drop-in that was virtual that we did sort of morning and evening, and it was meant to provide a time for people from the global community that they could come and drop in sort of outside of Pacific US business hours that worked for them. And we were also starting up our virtual summer school at the time, which was like a 1-week virtual course. So we're starting all this programming for the delegates. And at the time, so that was like our programming. And then we also had these attempts at facilitating networking specifically. So programming is usually pretty focused on learning to use the RSP. You can come as an individual and just sort of learn and try to prepare to do your science. But then this was all trying to get people to meet each other and sort of building a cohort, which is the theme of today. So we had something that we called the DP0 New Friends program, where we tried to pair up someone who was a delegate who was also very new to Rubin with a long-term science collaboration member. And that was basically email contact with the option to meet virtually, so that are just people who were new to Rubin had someone that they could ask all their naive questions to. At this time, we were also trying to facilitate Data Preview Zero working groups. These were delegate-led sort of open analyses of DP0 data by scientific topic. We would kind of ask delegates what they wanted to work on and try to form working groups out of those. And we would list them on our DP0 websites at the time. And we would talk about them during the co-working sessions and during Stat Club and make breakout rooms based on those co-working groups to try to get people to meet each other and provide a venue for them to work together. And then we also had those open co-working sessions, which were essentially drop-ins during the Stat Club, and then also during our delegate assemblies, where we would start with a hands-on tutorial or a presentation, and then the second hour, we would usually do some co-working. These were also just delegate-led, so it was kind of whoever showed up and whatever they wanted to do or learn about, that's what would happen in the working group or in the breakout room that day. So what worked and didn't in these attempts at facilitating networking in these ways? For the New Friends program, we found that pairing by science interest was actually pretty challenging. Not everyone was well matched. We had on order of like 10 to 20 new people and mentors. And so they weren't very well matched. We kind of left this to be very organic, which I would not do again. If I was going to repeat a New Friends type of program, it would be limited term with a bunch of like very set engagement activities, not just a pairing and off you go, because I don't think that worked super good. Kind of fizzled out. No one was mad, but it could have been better. For the Data Preview Zero working groups, we found that we tried to make them sort of like grassroots, organic. People show up and then they just sort of say what they want to do and we get them together. That also didn't work super well. Because so many people were new to Rubin, they would come and they wouldn't really know what they wanted to do yet. And we didn't have anything we're not there to tell you what to do with the Rubin data. We're there to help you with what you want to do. So these kind of working groups, they worked best when they were led by science collaboration. So like a group from TBS would show up, they'd get a breakout room and they'd be very happy working together, but also they usually already knew each other. So that's kind of why that worked better. And in surveys, delegates consistently reported, oh, I don't have enough time to work on Rubin right now. And you need time to dig in and to do this kind of thing. For our open co-working sessions, yeah, this one also worked best when groups turned up who knew each other already. And in this case, groups that did turn up who already knew each other, they had Rubin staff just sitting there to help them with whatever it was they were already trying to do. And so, I mean, that's kind of what it was designed for. So it did work for that, but it didn't work in facilitating networking. It worked to help people do what they already wanted, but it didn't help them to meet new people in the way we thought it might. During this time, as we were running this programming and trying to facilitate networking, we were also trying to specifically support delegates who are at small and underserved institutes. For this talk, that it just sort of includes, it's a bit of a catch-all, non-R1, primarily undergrad, minority serving, very broad umbrella term for this particular talk. And what we did is we ran one-on-one virtual meetings with faculty and undergrad at small and underserved institutes. This was run over 2022 to 2023, and this interview style really served two purposes. One, we on the Rubin side wanted to learn about the barriers and challenges that people at SUI's had in trying to access the data. Like, did they need more tutorials? Did they need simpler ones? Did they need time? What was it? And at the same time, we wanted to sit down with them and provide an accelerated onboarding service and custom advice. So we found out what kind of science they wanted to do, or even their area of interest, and then we can recommend a set of tutorials, or, oh, you need this documentation, or look at what this other person did, that kind of thing. So try to get them accelerated. We learned a lot through this, and some of the outcomes that we managed to implement was to continue to offer these one-on-one meetings because people liked them. To try to create more spaces for SUI networking. At the past RCWs, there were some SUI-based sessions, and now we have this, like a half-day session, which is great. We also try to support initiatives run by the SUIs. They know best what it is that they need, and they can sometimes go out and get funding to do it. And then on the Rubin side, we can come in with the time and the effort to give like really custom seminars. So we can find out what the science topics are, where the people in their group are starting at, and we can design sort of custom seminars that sort of take them from where they are to where they need to be. Throughout all of this too, we're starting to sketch out a Rubin course for undergrads. And this is not an learn astronomy with Rubin course. This is more going to be targeted at sort of fourth year or like upper undergraduates. They've kind of had some astronomy. They're ready to start their summer research program. They can do this course, or their professor can implement this course so they can get credit to ramp themselves up and then be ready for summer. So we're starting to sketch that out. I think we're a couple of years out from being actually able to supply modules that have like really useful problem sets that professors can use to run sort of seminar classes and get their students credit for learning the Rubin specific aspects of astronomy that they need in order to start their research. One of the special challenges we found in networking with SUIs, like through the one-on-one meetings, is staff at small and underserved institutes do a lot of teaching. They have very little time to lead a research project. And so what they were communicating to us is that they're looking to contribute to other people's research. So in this case, it's the science collaborations that are really the right place for it. The Rubin community science team we don't lead papers and we don't lead research. We support people in learning so that they can do their own research. But really, the science collaborations are the right place to collaborate and contribute to other people's work. But typically, applications to join an SC, a science collaboration, usually asks what kind of research projects people want to do in that collaboration, or how much time they're willing to give and to develop science collaboration communal software and that kind of thing, or at least the applications used to ask for that. We found it's very challenging to design a research project that people with limited time can join and make meaningful contributions to. But we're just going to try to continue to be a resource in supporting the networks that you're all sort of building. For example, by giving custom training and to help people maybe take the first few steps in getting familiar with Rubin before they try to join a science collaboration, because we can help with that as well. So this is something we don't really have a solution or any ideas for this particular challenge. We just acknowledge it exists, and we're trying to find ways to help people with this particular need. Overall, delegate engagement was great. This is just an example of some slides that we did, like some flash talks from delegates where they could say what they had been working on. Got a lot of good delegate feedback, which was really useful. We try to implement it right away into the CST programming. For example, everyone loves the notebook tutorials and they find that the most useful. So we've massively expanded our notebook tutorial offerings for Data Preview 1, because we know that's the first place that people turn to. We also learned through talking to people that Data Preview 0 did not equally help everyone to prepare. There's a big learning curve and that takes time. A lot of the students felt lost when they were sort of sent in to learn on their own. So now we do try to develop our resources with what we call the unaccompanied undergrad in mind, that they've been sent into our resources to try and learn stuff so that they can do some summer research. And we're trying to make sure that we're like at least ready to help them, or at least know that they're out there and have that context for when we're trying to help undergrads. And then there was a separate issue where DP0 simulations, they were just very limited. And so not all kinds of science were represented. That's kind of separate from today's topic of networking, but it was an issue with DP0, which prevented some people from benefiting. And I think I'll just leave it on this one, rubinobservatory.org, for more resources for scientists.
We're extra thankful for Melissa for going out of her way to share these resources and ideas with us, given all the demands on her and her leadership of this workshop this week. We have time for a question from Melissa from the room. And I'm walking over to Fed Bianca with the mic.
Thank you, Melissa. So one comment is that it's true that the science collaborations typically do ask, what do you want to do with Rubin? I think at least in the case of TVS, which is the one that I'm most familiar with, it's really just intended to prevent an influx of people that just apply because they can and have some idea of what they want to do. But we struggle with the wording to make it sound as inclusive as we mean it to be. So I mean, the CS team should definitely encourage people to do that anyways. I know that's not probably going to solve the problem. We can continue working on it. And then it's interesting that the programs that require like human interaction between people that didn't know each other are the ones that had the hardest time taking off. And so it sounds like we have like a socialization problem more than a support problem, right? So how can we foster people just like ease to communicate and get to know other people in addition to support their science? Maybe something that we want to ask ourselves, maybe, you know, aperitivo or something.
Wait, what was the last thing that you said?
Offer aperitivo, offer like a drink.
Oh,
Offer social time so that people can just like, maybe before some of the science assemblies, we can do just like, hey, come have coffee with everybody else on Zoom.
Yeah, that's true. That is not something that we have ever tried to implement into our delegate assemblies. We're usually trying to have content for the full hour is kind of what we aim for and sort of end up doing. Yeah, so the virtual is a challenge. It's nice to be here to interact with people. But yeah, we could try more virtual socials, which, yeah, I haven't tried.
We'll hear Leslie's question, and then that'll be the last one for the session or this talk.
I guess not really a question, but just to piggyback on what Frederica said, you know, I really, really enjoyed those lightning talks this morning about the people and their career, like both what they did in their career and a little bit about their life. And maybe that is the thing that then you add to the aperitivo and then it makes people more social. I just thought that was so great. Really appreciated that.
Actually, one of our like most well-attended delegate engagement events was the Flash Talks Day from, I think this was from Data Preview 0.1. And then, yeah, that kind of thing does work really well. It's good.
Let's thank Melissa one more time. Great. We'll now hear from Brian Scott about the Data Science Fellowship Program.
It was really cool this morning to hear about all of the undergraduate focused research experiences and transitioning students from not knowing that they maybe even want to be an astronomer into being an astronomer through those experiences. The DSFP is not that. The DSFP is a program for graduate students in astronomy to transition them into working and thinking about the kind of Rubin paradigm of data-driven astronomy. I wanted to take a second to talk about the team. So Lucian Wolkowitz and Adam Miller were the founders of the program, and they were kind enough to entrust me with it over the last few years. I also wanted to draw attention to the contributions that we get from Sierra and Northwestern staff. We often ignore the kind of administrative people who really make these programs possible. And Peter Anglada and Janet Lyons are amazing, and the program would not be possible without their contributions. So I really wanted to highlight their work. We also have a number of philanthropic partners that allow us to make cost or institutional resources, not a barrier to participation in the program. So the DSFP is about 10 years old now, and it's intended as a supplement to graduate education in physics and astronomy. So it's not a replacement for the training the graduate students are getting in their programs, but it's something additional that is meant to sort of enhance the data specific skills. So in particular, we're thinking about how do we create leaders in this next generation era of data-driven astronomy. And I'm going to focus a lot on that leaders part and not so much on the data-driven part, but I do want to talk a little bit about the overall program structure as well. So our motivation is this recognition that open data alone is not sufficient for inclusivity. There are a lot of other things that a lot of other conditions that need to be met for people to be included in this data-driven paradigm. So in particular, there are some things that are very hard for us to address through a program like the DSFP. So we can't address things like the time and money that's available to researchers, but we can address the experience gap and make sure that the community as a whole has enough experience to importantly, meaningfully engage with the scientific questions that Rubin will be able to answer. And so I really want to focus also on this idea of not just engagement, but meaningful engagement and how you teach people to engage in meaningful and significant ways. So our curriculum is 6 topics. So we cover astrostatistics, machine learning, time series methods, databases and software, wide field image processing, data visualization, and ethics. And so each topic gets a week in the program. And again, the focus for this talk is on the cohort building aspect of the program. But if you're interested in how we think about the curriculum, I'm happy to chat about that or answer questions about that as well. So a lot of the philosophy of the program comes out of some kind of deep educational theory. So I really like this quote from Ken Bain, who's a researcher who focuses on higher education pedagogy. And he says that teaching only occurs when learning takes place. And I think this might sound backwards or it might sound a little overwhelming. So it might sound backwards in the sense that we envision that teaching is somebody like me standing up at the front of the room and depositing information in your heads. But that's not really how teaching and learning happen. Teaching and learning happen when people feel empowered to engage with material. And so a lot of what we have to do as teachers is create the conditions by which fellows in DSFP or our students are able to engage with material. And I draw on the work of an educational psychologist named Carl Rogers about how to do this. And there's kind of 3 big ideas. One is that human beings have a natural potentiality for learning, that learning is a fundamental need that humans try and fulfill along with other needs. And they're only able to fulfill these kind of higher order needs like learning when their more basic needs are also being met. A lot of significant learning, so the kind of deep, lasting, and pervasive learning, is learning that is acquired through doing when all of the person's aspects of their identities are met and supported. So to accomplish this kind of philosophy of learning, we use a cohort-based model. So we admit a new cohort of fellows roughly every calendar year. Sometimes it's every other calendar year, but roughly every calendar year, we admit a new cohort. And fellows join the program for 2 years and 6 week-long sessions. So this is different from other kinds of winter schools and other kinds of external training or graduate supplements, in that these are often 1 week long experiences where people come together, build deep connections with one another, and then depart at the end of the week, just as those deep connections are really becoming solidified. So we have a 2-year structure. So the fellows keep coming back together again and again and again, and they are able to develop mentorship relations both within their cohorts and between the cohorts. So we've successfully completed 23 sessions, and we've had 7 cohorts who've been through the program of 20 fellows, and our 8th cohort just began. Our cohorts come from all over the world. So we've had fellows come from nations on every inhabited continent. And if you know any optical astronomers or graduate students from Antarctica, definitely send them our way so we can remove that caveat. But we also focus the program on having intellectually diverse cohorts as well. So our view is that Rubin is going to touch every area of astronomy. So we encourage applications from fellows in subfields that might feel very removed from the core sort of Rubin and optical astronomy communities. In terms of once the fellows join the program, we really focus on modeling strong and positive norms within our academic community of learners. So fellows are really given ownership over what the program structure looks like, what the rules, how people engage with one another, and we encourage feedback often throughout the program so that fellows learn how to sort of construct the norms that they'll bring into the rest of their careers as astronomers. Obviously, a big part of the program is expert instruction and mentorship. So every session, we bring in experts in every subfield, and we provide a large number of mentorship and networking opportunities between our expert instructors and the students. And we also have kind of informal mentorship opportunities. So this picture is from a architecture tour that I led of downtown Chicago. This is an opportunity for the fellows to have sort of informal relationships and think of Adam, myself, and Lucianne as additional mentors within their mentorship network as they go through their PhD. So if they need to go to someone for advice who's not directly in their institution, they have other resources they can draw on through the DSFP. We also have yearly check-ins with all of the fellows to find out what's going on, how the program is or isn't serving their needs. The program is travel-based, so we visit institutions all over the country, and this also allows fellows to have opportunities to network at each of the host institutions. This also opens up opportunities for professional development. So for example, one of our past instructors was a scientist who had gone into California state government, and this facilitated a visit to the California state capitol where the fellows were able to meet with physicists who are working both in policy to support science and also how science can support policy. As I've mentioned, a big part of the program is the cohort mentorship. So within each cohort, fellows are encouraged to support each other, but also the fellows in the more senior cohort are encouraged to support the more junior cohort as they go through both lectures and active learning and hands-on learning opportunities. The end of every week is a hack session where fellows have about basically a couple of days to formulate a research question, work together to identify how that research question can be addressed using the methods from that week, and then work together to attempt some aspect of the problem and share back to the room, where that's another opportunity for them to practice their scientific communication skills. One of the things that we're working on is thinking about hack continuation. So this is a common problem with hack sessions that sort of end after a day, is projects don't tend to be completed. And a lot of the research on these kind of hack continuation is that skill diversity within the team and intention of team members allow these projects to continue. And those are things that we think the DSFP's cohort model is really well positioned to allow, both in terms of the diversity of thought within the cohorts, and also the fact that there's an extended multi-year relationship that the fellows develop. And we've had one example of a hack project that turned into a archive posting, which is predicting the winners of The Bachelor using a machine learning algorithm. So I'll skip the future goals, but I do want to mention some demonstrated impact, which is the program is now 20 times oversubscribed. We've produced 56 PhDs, 35 people have gone on to postdocs, and 14 of those have been prize fellowships. We've also now produced 4 tenure track faculty, and this is essentially from the first couple of cohorts. So most of the fellows that are been through the program are still in graduate school, and many of those that have graduated from graduate school are still postdocs and are likely to become future faculty. So I'll leave it there.
We have time for a question for Brian. Anybody in the room would like to ask one? This will be Jesse Mason.
Congratulations on all your successes. I wanted to ask you if you had to narrow down why your program has been so successful to maybe 2 or 3 key items, what would they be?
Yeah, I think I sort of glanced over this, realizing my talk was probably much too long, but I think it's the strong community norms, and I think it's the ownership over the community that we give the fellows. So we set a tone from the very beginning through basically our code of conduct document, which is more a statement of community values. that of what we expect. And we expect a culture of openness, we expect a culture of integrity, we expect a culture of collaboration. But within that, the fellows are able to sort of define the norms of that community. And we address that again at every session. So every session starts with an in-depth discussion of that document, a reminder of the responsibilities that the fellows have to one another, but also gives them an opportunity to describe whether those responsibilities are appropriate, whether there should be additional responsibilities, whether there should be other community norms. And so it's that culture, I think we create a really positive culture. And that means that the DSFP is a source of support and strength for the fellows that they're able to bring back to their home institutions, rather than sort of an additional thing that is maybe a drain on their intellectual or emotional resources.
Great. Before we thank Brian one more time, I just want to observe, I know I'm preaching to the choir, but how amazing to hear that we're part of this community today, which is able to fully experience and acknowledge that community norms and ethical and productive collaboration lead to PhDs, lead to faculty jobs, lead to scientific productivity. It's not just something that people do because it's a touchy-feely thing. It's a fundamental part of being a successful scientist. So thank you so much for sharing that, Brian. And everyone, as you're thinking and getting ideas from these conversations, don't hesitate to add ideas for discussion in the shared document. Here's Jenna. I'll bring up your slides. Thanks.
Before I start, I'm wondering how many people in the audience might be looking for postdoc jobs, if any of you, within the next, say, 2 years. So a small number. Or anybody currently a postdoc? No. Okay, so I'm going to talk about postdocs, and I don't know how relevant it is to you all now, but it hopefully will connect to what other people have been saying about community building and cohort building and the communities that we generally try to support in LSS TDA. So the lack of postdocs in the audience notwithstanding, when I was a postdoc and I had questions, I would often turn to, for answers to those questions, other postdocs. And those folks were often the best people to turn to because, for one thing, they had more time than faculty to engage in conversations. They were often world-class experts in their fields. And for me, very importantly, they were unlikely to ever write me a letter of recommendation. So that helped me feel very free when I asked my questions. So today I'm going to just briefly, so my experience, it illustrates some of the value one can get from postdoc networks when you do become postdocs. And I'll briefly review some of the things LSS TDA is doing to foster such networks among postdocs. Is that blurry? Or is that, oh, is it me? Okay. So why are we focusing on postdocs in addition to, as you've already heard, undergraduates, graduate students, and others? In large part because postdocs are a crucial link in many contexts, especially at R1 institutions, but even beyond that, in the research chain. Postdocs really do, I think the National Academy of Science noted that they're actually the most crucial link in many research endeavors in that research chain. So it's important that we focus on them. And also, as we've heard today again and again, and yesterday, that the Discovery Alliance is a network. And in addition to providing programs for the broad Rubin community, we are a membership-based organization. And one of the things we try to do is foster communication and collaboration among our member institutions. And since postdocs are this key link in the research chain, networking those postdocs is important to our mission of building this communication and collaborative network among our members. Also, postdocs can be vulnerable in a way that's different than what we've heard earlier today about undergraduates, for example, they're vulnerable in the sense that they're often isolated. Unlike students that have their classmates or they're naturally part of a cohort, postdocs aren't. A lot of the time they're an individual researcher working with an individual faculty member, and they have a high risk of becoming isolated. They are transient in their institution, sometimes not incorporated into the structure of an institution the way academics at other levels are. And they're sometimes in a place of career vulnerability. If they don't have the ideal advisor, that can be a very challenging power dynamic for a postdoc. Those are the challenges. That said, as I mentioned in my opening, the value for networking postdocs is very high. They can turn to each other, and often that peer networking, mentoring, can be the most valuable aspect to their career development. So it's their high need group and also a high benefit to networking. So the Discovery Alliance, I think in 2021, launched or started the Catalyst Fellowship, a fellowship for primarily postdoctoral scholars. The first cohort started in 2022. And taking into account this philosophy of cohort building, we went beyond funding individual postdocs to really focus on building a network among these postdocs. So focusing not just on their current research, but impacting their entire careers, nurturing future leaders, and also building on the norms, changing norms that Brian Scott just mentioned, also helping them, training them to impact the field by bringing positive value of contributing to the community into their next career stages, their current and also future career stages. So we did this by connecting fellows with lasting resources, in particular each other, through cohort building, also the science collaborations, as you've also heard today, for each postdoc, a diverse set of mentors, and also some leadership training and support for their community engagement activities. So our postdocs aren't tasked with just doing research. When they apply, they have to also tell us how they're going to impact the community. What activity are they going to do that goes beyond their publication of papers? So that is a norm that we try to propagate in this program. So they have annual symposia. That is where we provide some of the networking and leadership training sessions to foster this cohort building. They have monthly virtual meetings and their own Slack channel, which those of us who run the program don't peek in on, so they can say, whatever they want and then bring it to us if they have some challenge. As I mentioned, they have mentoring committees, each of our postdocs, and a diverse network involved in the program that includes some postdocs situated at non-R1 institutions. And also we have social scientists involved, both as fellows and senior members of our team that are actually studying the practice of science and the career development of scientists. So our postdocs have the opportunity to engage with folks who are studying how to be a scientist, what are the things that one needs to do to be successful and have a meaningful career. So our funding was initially for 2 cohorts. We are now, as I said, the first one started in 2022. We're in the process of seeking funding for additional cohorts of postdocs. We have just submitted a proposal that would lead to 22 new postdoc positions in Europe if it's funded, and at the same time we're seeking funding for additional postdocs outside of Europe. And some of those features that I mentioned for the original Catalyst Fellowship would be continue into this new, what we're calling a Catalyst co-fund iteration of the Catalyst Fellowship. It's called co-fund because of the nature of the European funding that we're applying for. Okay, so I mentioned the fully funded postdoctoral fellowships, But moving beyond those, we're currently about to launch or launching right now initiative to expand the network of postdocs that are funded, externally funded, but are working on LSST science. And I won't say a lot about that because the deadline just passed. But our goal is to, again, build networks among postdocs, select a postdoc from each of our member institutions to come and join our annual symposium, receive some of the training that I mentioned and mentoring opportunities, and have access to additional mentorship and some mini grants. Okay, so I'll just summarize quickly that postdocs are an important nexus for a lot of the research that's being done. They have need for cohort building and mentorship, and benefit greatly from networks. Therefore, we have ongoing new and planned programs that create and strengthen networks among postdocs.
Great, thank you. Questions for Jenno? And the reason I always say what I'm doing is for the remote people that can't see. I'm walking across the room to hand Luis the microphone.
Thanks for that presentation. I'm wondering a little bit about the new postdoc program you just mentioned that is meant to connect other LSST researching postdocs. Is that quite international as well, or is that mostly in the US? And how are you grabbing all those different
Fully
folks?
international. So every LSSTDA member institution, whether they're international or domestic or expansion partners, can have one postdoc that's a part of that network. And I just realized something else. I was talking about the postdoc aspect, but some of our postdocs, they all have in their mentorship committee one mentor that is from an expansion type institution. And often those folks are bringing undergrads into research. And so we have several cases where our funded postdocs are working with an expansion mentor who we provide with $50,000 worth of funding for being a mentor. They then bring those undergrads into the research group that involves the postdocs. So hitting on that sort of tiered model where there's one faculty member and they have a postdoc and then multiple graduate students. And in some cases, that's been very successful for the various participants, including the undergrads.
Okay, Kelly, we'll get the last question for Jenno. Here you go, Kelly.
I was just curious for when an undergraduate is interested in joining this group, how would they apply and what are their steps that they would need to take?
So for undergrads to get involved in some of the research or these programs, it would have to go through, we have a set of expansion mentors that are at expansion sites. So it would be through those particular those faculty members. So if we have those listed on our website, if you are at one of those institutions or nearby, it would be through them.
Great, let's thank Jenno one more time. And now our last talk for this session is going to be from Pat Burchat. And let's see, we have that on. This is yours, yeah.
And I click forward on here. Yeah, I think it's the very last one. It's on, yeah, UIUC. Great. Okay, so I'm going to talk about student cohort building through two different programs that have been funded through the LSST Discovery Alliance. And one is undergraduate focused and the other one is graduate more graduate student postdoc and beyond. And the first one you've already heard about, so I'm only have a couple of slides on that. So 6 cohorts, and let's see if I can move this thing up out of the way a little bit. There we go. Okay. So 6 cohorts of undergraduates and sometimes graduate students have been supported by what used to be LSST Corporation and then becoming Discovery Alliance, to attend now 6 Rubin community workshops, or in the old days, project and community workshops. So that started in 2018. And the first 3, I was involved in leading. So that was 2018-19. And then the first one post-pandemic. And then Ryan took over, which is fantastic. Okay. You always need succession planning. Okay. And have someone else take over. So Ryan's been doing a terrific job. And as you've heard, the undergraduate program includes, still tours of Mirror Lab, which are just so special. And in some cases, the machine shop, engagement with scientists and engineering, interacting with students from other institutions, a really important part of it. Attending the plenary and parallel sessions, some designed just for students, career panels, poster pitches, and presentations on their LSST and Rubin research projects. And actually that one in the bottom right, that is the very first cohort on stage at probably one of the resorts north of Tucson. So over the years, we have, let's see if I can go forward here. There we go, done exit surveys. And so overall, very positive. In some cases, students say, life-changing, and that for the first time they felt like scientists. And actually, I remember that the very first one in 2018, the students came into big auditorium ahead of everybody else, sat down, and then everybody else came in. And that was a really well-attended project and community workshop with an appropriately sized room. It was almost full. And so when the students then stood up to go up onto the stage, it was the first time they actually saw who was there, because it was the opening plenary. And they were terrified. Okay. And then they did a fantastic job, and then delivered their posters. And afterwards I asked them, how did it go? And they said, everybody was so nice and so friendly and so interested in my work. And that I think was what was life-changing to them. The feedback has led to adjustments to programs. And so I just give you a few examples, and actually it hits on themes that came up in earlier sessions. It's all kind of weaving together, I would say. So for example, students said, overall amazing experience. My only suggestion would be to offer the option to stay more days, because back then it was a 2-day thing, Monday and Tuesday, and they left Wednesday morning, and they were like, do we have to leave? Can I change my plane ticket? And so we've adjusted the program so that they leave Thursday mornings, but they have the option of staying longer with support of their advisor. And so again, hearing that input, they want to stay all week often. The students were impressed with the career panel, with the diversity in terms of professional background. This was in 2023, and the even split between male, female. However, the students wish that there was more diversity along other lines, like race, ethnicity, sexual orientation, et cetera. So the outcome was aim for a broadly diverse panel. Then the next year, the students really enjoyed the diversity of the panel. So that was great, but they wanted more non-PhDs. Okay, like what can you do with a bachelor's degree, or maybe a bachelor's and a master's or a co-terminal master's degree? Outcome, aim to include more non-PhDs and non-academic career opportunities on career panels. And again, this is kind of things we have heard about earlier today. Okay, so I'm going to tell you a little bit about the Dark Energy School. This is something that the LSST Corporation funded for 3 years. So Dark Energy Schools 3 through 9, so 6 years of the 15 schools that we have done to date. And having the Discovery Alliance and back then Corporation support was essential for, it was the very early days of the Dark Energy Science Collaboration. And having that extra support where the early career people would apply for some travel funds, and it was just partial travel funds. And once they got it, then their mentor was much more likely to say, yes, I can cover the rest, and for you to go to the Dark Energy School. So the Dark Energy School, what's unique about it is that it is engaged learning. You heard in an earlier talk how teaching doesn't matter if they don't learn anything. And physics and astronomy education research is really advanced and really shows that engagement is important. What we do, though, is not engage with laptops at all. In fact, everybody appreciates that at the beginning of Dark Energy School, we tell them, laptops closed, no open laptops. They're engaging with each other. The point is we engage with our laptops all the time. And it's too easy to be distracted. And I always tell them, too, that research shows the only thing that's more distracting than having your laptop open is if your neighbor has their laptop open. So And also, it's just one day with 4 lessons. There's not time to like go into your laptop and learn a new code or whatever. That's for the Data Science Fellowship Program, okay? Here, it's thinking about questions, discussing the questions, understanding what the question is, maybe getting a little bit of the answer, and then being totally engaged in, okay, I understand the question. Now, I'd like to learn more about this. So you see here, actually I scanned it. I think there was one laptop open, okay? But, and people often comment afterwards and say, thank you for making us close our laptops. Okay, and so it is also a comfortable place for instructors to get outside their comfort zone because they know they have to teach with engaged learning. And I coach them on that and what that is. And so it is not asking like, so does anybody know the answer? It's like posing a question and then they get together in groups, and that's what they're doing here. And here, I love this picture right here. This is actually one of my graduate students, and here, a very senior person from the UK, okay? And clearly she's telling him, okay, kind of like, okay, this is the way we can think about this problem. Okay, so what is Dark Energy School? An all-day meeting on the first day of every desk meeting. Lessons are pitched at the intermediate graduate level, but everybody attends. Everybody here, I think, knows Robert Lupton. Whenever he's at a Dark Energy Science collaboration, he attends, okay, our school, and is a great student. We have 4 lessons, no laptops, and the topics, and this is why I'm bringing this up to you. The topics span, it's even though we call it Dark Energy School, it's not really about dark energy. It spans science, analysis techniques, software engineering, hardware, like the instrument and how that impacts your science, algorithms, and many other topics that are needed to do precise and accurate science with LSST. So it's relevant to other science collaborations as well. All the Dark Energy School lessons are on the web, on a public website. If you just Google Dark Energy School, you will get to the website. And it is slides, recordings, and other resources associated with every lesson. This is just 20 of the 50 or so lessons that have been given to date. And you can scan those later, but you can kind of see it's just topics all over the place. Like, how does the LSST camera work? And how does that impact your science? What's a Gaussian process and how do you use that? Okay. And again, they're all done with engaged learning. And then my last slide here, this was the Dark Energy School just last week. And I want to point out, and this, I have a pull request on our GitHub to get this, the new materials for these 4 lessons up onto our public website. It should be up in a day or 2. And so you can see that, you know, the first one was what's happening on the mountain to deliver your science. So active optics and the point spread function, photometric calibration and the collimated beam projector by Ilana Urbach, who you heard earlier in one of those lightning talks. And that's a picture of her as seen in the New York Times. Do you see in the lower right-hand corner of that photo? That's Ilana right down there beside the telescope, okay? And like these 2 teachers, they're both early career. Guillaume just defended his PhD about 2 weeks ago in aeroastro at Stanford, and working with Steve Kahn, actually, was his mentor. And then Ilana is a kind of postdoc, early career kind of scientist. And they gave these amazing Dark Energy Schools here. And then like lesson 3 was making a difference, templates, transients, and troubleshooting in LSST by Bob Armstrong. And so if anyone interested in time domain physics, you know, that is a fantastic lesson. And then what can you learn from Data Preview 1? And it wasn't about, you know, learning how to access the data. It was brainstorming on what projects you might want to do. We have our data, desk has data at NERSC at LBL. Should you use that, or should you use the data science, the platform? Yeah, so anyway, I think the Dark Energy School, which has benefited greatly from the Discovery Alliance for early career travel support, will benefit all the science collaborations and all levels of people wanting to get science out of the data. Thank you.
Great, thank you, Pat. Any questions for Pat, our last talk of the workshop? Here, Kelly.
It's not a question, but more so a comment. I love that they have no laptops. I think it's really important that people really do engage in their learning because it truly is the way that we do learn, right? Like, so it really is truly amazing. And I bet you have incredible results with that.
Thanks. Yeah. Yeah. And it takes courage to tell people to close their laptops. And it also takes courage for instructors to really use engaged learning and not slip back into how we usually teach just very passively, which has been shown to not work. Okay. So, yeah. Mhm. Yeah.
Okay, Brian, please.
So I've been to a few of the dark energy schools and it's amazing and super unique. And I think the coolest thing about it and what stood out to me from the very first one was that there's senior people learning things and learning like different things from what the junior people are learning, but everyone's learning together.
Yeah.
Do you have ideas about how that experience can be replicated outside of the context? Because I think it benefits a lot from going hand in hand with the desk meeting. People are there, maybe add an extra day of travel. But is there any other context in which that model and that experience of having junior and senior people learning together, having conversations together can be
Right.
replicated?
Yeah, I think you kind of already mentioned it, it's kind of by integrating it in another thing, like it could be as part of the Rubin Community Workshop, because people are going to come anyway, and maybe have it as part of that. So yeah, so I think integrating it as part of a bigger meeting. And actually with the fact that there are experts in the audience on any one of those topics, but not on all of the topics. Like there's no one in the audience was expert on all those topics. They all had something to learn. So when I coach at the beginning of, expectations for how people interact in the groups, I explained that if you're already an expert on the topic, your challenge is to not just blurt out, oh, I know the answer, okay? But rather, your challenge is to think of questions to ask the other people in the group so that the light bulb goes off in their head independently without you telling it. And so I give them a challenge, to not blurt it out. So, and they kind of like all like nod, yeah, okay, I'll do it. Yeah.
Great. One last question for Pat.
Oh, sure. So I guess my question, I'm Parker from Hartwood College, undergrad, PUI, SUI. My sort of tie-in is I would love to see this being done with a set of undergraduate focused workshop kind of a thing. Very much active. I've participated in these before at Green Bank and Arecibo with a big consortium, and it worked just like what you're talking about, just like what Brian talked about. It's really active. It wasn't coming to talks. It was people working in groups to solve problems using, say, the Rubin data. So we did this with alfalfa data instead. But I would love to see that kind of a thing for undergraduates. And I think Jenna said that maybe we should have that as like a boot camp prior to this. So it's earlier in the semester, and then the students come in, they've already got a lot of experience under the belt, and they get a lot more out of this event if that is going beforehand. But that's my comment.
Yeah,
I would
great.
love to see more of the active learning at one of these. Yeah.
And I think one of the challenges is you need an organizer who's going to almost assert themselves to coach the instructors, because it's not necessarily a natural thing for the instructors. And so that coaching part in advance, and fortunately, like everyone who is teaching these lessons, I didn't put everyone's names up, but we're willing to meet, at least a week before. And often it was just going over their first 5 slides or so, and, giving them advice on how they might integrate questions right from the beginning. Rather than starting with a 15-minute introduction, after 1 slide, you already have a question for them to talk about. And that really helps with that interaction. Yeah.
Well, let's thank Pat again.
Thank you.
Okay, excellent. I think we have about 20 minutes, maybe just shy of 20 minutes left in this session today. And so I'm going to suggest again that we have some informal breakout discussions. I know some people have already made new connections, and you might have some conversations you'd like to continue. I also know that a couple people in the room wanted to suggest some things to talk about before lunchtime and didn't have a chance to do that. So I'm going to, I'm going to suggest that we do that. And then Andrew here is going to set up a breakout room in case some of our long distance participants would like to just get together and either gab or talk about some specific outcomes that you are interested in from this afternoon. I asked our remote participants to please, like you did this morning, record some notes from your conversation so the rest of us can benefit from it, because we won't have time to come back and do report outs. But one reason that I was asking folks to please put your name into the institution into our shared document was so I can send everyone a follow-up email. Here's the documentation. Do you want to continue these connections? Then to help us stay connected afterwards. So again, if you're interested in that, put your info in the Slack or email it to me and I will add it to the shared document. And so we're going to hear from Parker, who's going to say some things on his mind that he'd like to discuss.
All right, this was one of the topics I was about to suggest, but we had the 4 sections already, which were great. It's even better time now. So it's exactly what I was just saying. I would love to see discussions about the possibility of sort of this group meeting or the undergraduate interested folks meeting for, say, a 4-day workshop, either right before, either I was thinking initially maybe right before this, but maybe the timing would be even better based on what Jenno said, and maybe earlier in the summer. And so who is interested in discussing that ultimately? I mean, as I've said, I've got some experience in that. And our meetings are more 40% talks. You'd have experts come in, but then 60% breakout groups. And it'd be several undergraduate students and then maybe a faculty lead and maybe maybe a graduate student, but it was much more active. So I would, yeah. And so the 2 ideas of that kind of a thing and an undergraduate focused event, maybe separate from this.
Okay, so Parker is going to be one nucleus. If somebody wants to start a new conversation focused on what it could look like to have an undergrad-centered event, similar to some of the themes we heard from the Dark Energy School and otherwise. Were there any other new topics that folks want to propose? And I want to make explicit that students who are in the room are invited to propose a topic that's student-specific or not. Everybody's looking down. Well, I think it would be very appropriate for our one new nucleated session to be a conversation of what might it look like? What's our next in-person meeting going to look like? Is it going to be something that is bigger, separate from the Rubin Community Workshop along these lines? Oh, did you want to add an idea? Oh, sorry. Or something else. So, and again, please, as always, take your notes in the shared doc or pass them off to me somehow and we'll get them recorded. And again, if you're interested to continue being connected and hear about, next steps, next opportunities, please somehow communicate your name and your institution that you've been in the room here. And then, yeah, at the end of the session, I'll just do a brief thank you to everybody. But yeah, find Parker, find whoever you want to talk to. Thank you all so much for sticking around for as much as you did of the workshop.